All right, so welcome back. I hope that the exam wasn't too bad and you were able to kind of piece together things, and I'm pretty good about giving a lot of credit for your work. So hopefully it'll be all right. In today's lecture, we begin the study of algorithms. And it's a very important topic for this class. We'll spend several weeks on it, and it's related to when we get to graph theory, implementing an algorithm and programming it. And on that note, I'm going to program today as we go through the topics, right? So today we're going to introduce what's known as pseudocode, and we're going to implement some algorithms, some basic, simple algorithms. So with that being said, I'm launching Anaconda, even though last time I used VS Code, just for simplicity so other people could follow along if they don't have VS Code installed. Not going to update. And what I'm going to do is I'm going to launch a Jupyter notebook from Anaconda. Okay, so navigate to some directory where I want to do things. This semester I've made so many directories for different reasons. Where do I want to go? I don't know. I guess HT teaching might be good. And I'll just put it in here. Oh, I already have one there. Okay. So new Python 3 Jupyter notebook. And I'll zoom in a little bit to make it a bit bigger there. Okay, so I'm going to basically be typing out like lecture notes as we go, because you can do that in Jupyter notebooks. You said it right there. And to do that, I'm going to begin my Jupyter notebook with a markdown cell. And again, I've talked about this before. There's like markdown cheat sheets you can look up and like know the syntax. So I already know the syntax for what I need to do. I like to put these little bars like that, so when I run the cell, you can distinct them from like the rest of the stuff. So this is, I forget what number this is, lecture something. I'll just say algorithms, whatever. So if I press shift return or shift enter, it makes it look nice like that. Okay. So, all right. So we need to begin with a definition. So maybe I'll put some bold text in there. Definition. We need to define formally what we mean by a algorithm, right? So I will follow the convention of Rosen. It's a little bit different than the definition given in your Zai book, but it's the one I want to work with. So an algorithm, so make that italicize, that is a finite sequence of precise instructions for performing a computation or for solving a problem, taken directly out of the textbook. Okay. So, all right, if I press shift return, I'll have like a nice little definition. Now, if I were in your shoes and you're following along with this and you want to have like a nice notebook that maybe you could host on like a GitHub repository or something, I would go in and like add more, right? So algorithms are important, blah, 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 give the definition, and then kind of make it nice, make it look like a professional looking document, right? Okay, so a finite sequence of precise instructions for performing a computation or solving a problem. That's our definition. And the best way to illustrate what an algorithm is with a problem, so like a simple problem that we can, like, I don't know, discuss. So maybe I'll make a problem here. So problem 1. This is like a motivating problem for algorithms. So find the maximum element in a finite sequence of integers. So this is a problem, right? So what's nice about Python is that we can the code is so similar to what's called pseudocode that we can kind of type along as we're trying to figure out the pseudocode and think about it. So here, I'm gonna come down and make a list L, and I'm gonna put some integers in here, 5, I don't know, -1, 2, 8, 3, 1, or 1, whatever. They don't have to be distinct, but I'm just doing that, right? So let's think about this for a moment. So this is what we have. Just giving myself some space here. I can clearly see that there's an 8 there, right? So how could we kind of look through this list, this sequence, and find that 8? And how would we know that that was the biggest one in there? What can we do? So your response is see if each sequential element is greater than the last one. So if you're scrolling through it like that. Yeah, so somehow we need to scroll through that, right? So maybe we can type something out to do this. Let's start typing. So problem 1 solution. So here I'm going to put what's called pseudocode. Okay. And I have a very particular way of how I write my pseudocode. There is no standard way of writing pseudocode. It's just, so when I say pseudocode, I should probably say what I mean. It's instructions to follow to implement an algorithm that are language agnostic. They're not specific to a given language. They're just instructions that you can follow. Okay. So the way that I like to write these is I like to give a name, and I'll call this find max is the name I'm giving this algorithm. Right? And then I'm going to do input. You don't have to do all caps. I just, for whatever reason, had my caps lock on when I wrote name, and I left it that way. It doesn't bother me. So input, we have a sequence of integers, right? So maybe I can use LaTeX inside of Markdown. So LaTeX is math type in a sense. It's a syntax that you can use. So I can do okay, A1, comma, A2, comma, dots, comma, AN, I'll say. And I'll do colons here, and I'll say these are integers. And you can see that it kind of formats it that way. Okay? It's math type. It's going to format it as math type. And to enter in to a LaTeX block, you just do money sign, LaTeX stuff, money sign. Close out that block. Okay, so next we need our algorithm. So I'm staying consistent and doing all caps for the algorithm there. Now, it was mentioned maybe a little bit about scrolling through it, looping through it somehow, right? And we can do that with a for loop, right? So I don't want to number it like that, but I kind of do. Maybe I won't do it now. So I'm going to say max equals. So it's kind of convention to do colon equals when doing pseudocode, just to say you're assigning a variable. So colon equals a variable assignment. And we'll say that this is equal to A1, like that. Again, so it's looking like, let's see what this looks like. Yeah, I'll number them. It indents it a little bit, but that's fine. Okay, so max that, right? And then we're gonna use a for loop to grab indices, right? So indices of the sequence. Like notice like here, there are indices for each of the elements of the sequence, right? So we can like check through them, each of those indices, if we have like a counter or something, right? So we can say for, in bold, like that, for I, colon equals 2, and then I'll make it bold again, 2, n, and I'm gonna make these math types, by the way. So you're like, watch me make it like kind of nice for you. So like I like that, and then like that, because you'll see that there's like slight variations in it. See how the I's slanted now and the N slanted? Okay. So for that, we want to maybe like indent maybe. I think that's how you would indent. Let's see. Yeah, that'll work. So we can say like, I don't know, I'm gonna make all of the like the for, the conditional ifs, the whiles, I'm just gonna make those bold so they like pop out to the reader. So if max is less than, I can use math type again, a super subscript I, then so much italicizing going on right now. Set the variable max equal to AI. And then for return max. Okay, so that's like pseudocode there. It's not Python code, it's pseudocode. Those are instructions for any programming language. I'm kind of annoyed that if is not indented, so let me really quick search if I can find a quick solution to that. Markdown indent. 2016 might work, I don't know. Bullet point. Maybe that. Okay, so go back into the cell, and then what happens if I do that? That's kind of gross looking, but at least it's like, and I don't know. I'll go back and I'll find out how to do it. There should be a way to do it. But it gets the point across. Okay. Okay, that's a general description. I called it find max. It has an input. It has an algorithm, name, right? So we should try to implement it now, right? Like, can we implement this code in Python or whatever language you want to implement it in? So, okay, maybe I can say like, okay, max, I typed max and look what happened. It lit up green. That means it's a keyword, right? So we can't use max like that, right? So maybe we can say max, maybe max A or something, I don't know, equals to L0. So indexing starts with zeros in Python, right? Like many languages. Even though here we see that there was a 1 for the pseudocode, we have to like adjust, right? And this is something that you will encounter a lot as people that are writing algorithms in your CS courses and your data science courses. Okay, so unless you're using Julia starts at 1, so then it would just be kind of closer, right? Okay, so now we need a for loop. So for loops in Python are easy to implement. So for I, so now we need to figure out how to like translate this into Python, 2 to n. So this is actually where you would need to know a little bit of Python, like built-in functions, right? There are a few that you would use, and one of them is the range. 2, I need to know how many things are in there, right? So what I can do maybe is say like n is equal to the length of L, right? And then put it in right there. I'm trying to make it match up here. Now, this might throw you off, and if you were like overthinking it too much, or so the pseudocode says to go to n, right? But and I put a 2 there, right? Really, where I should start at for that for loop is at 1, right? Because we have to shift all the indices down by 1, right? Because we're translating it from pseudocode to Python code. And I don't have to do anything here because the range function is non-inclusive at the tail end. So the last element is non-inclusive. It actually is going to n minus 1, not n, which would match up. Like we have to shift 2 by 1 and then n by 1. But the range function doesn't actually go to n, it goes to n minus 1 in this case. Colon, inside of the code block now. Notice the indentation, indicating that we're in that code block associated with that for loop. So then we need the conditional statement. So if max A less than Li, colon, we have to update our max. Max A is equal to Li. And then we can just type max A here at the very end. In Jupyter Notebooks, like code cells, this should show us what max A is. And it's an 8. Okay. It's all maybe because like I don't have like formal education and like programming stuff. I just taught myself. Like that like still surprises me that you can like write out like instructions and like piece them together and think about it, and then it does it. Like it does, you can like see it in front of you, like it does the thing. So realistically though, I want to kind of encapsulate this with a function so I can use it over and over again, right? So like I'll say like this is like way 1. And then this will be like way 2. Make it reproducible, right? Like you should never program the same thing more than once, right? And if you were to like give another list, you'd have to come over here and change something there, and like you'd have to change things, right? So let's make it a function. And in Python, you call the def keyword argument to say that we're making a function. And we'll call it find max, and then put in L, colon, and now we're inside the code block for that function. Okay, so then we just have to like do all the things over again. Like n is equal to length of L, max A equals to L at 0, for I in range 1 to n, colon, if max A less than Li, colon, max A equals to Li. And then return max A and exit out of the loop. Okay. It's kind of nice. Maybe we could make it a little bit better though, right? Like, what if someone else wants to use this and doesn't really know what it does, right? Well, one way to do that would be to get on Google, as many programmers know that they should do, and search like Python function docstrings. And I already know a good resource called Real Python. Okay, so somewhere in here, there's going to be something I can probably just like copy paste. So documenting classes. I just need one function. Good. This looks like a function. I'm copying that. I'm coming back over here. I'm pasting it right there. And then I'm just gonna say, find, like change everything. Finds the maximum element L. Parameters. Only thing it is L, and this is a Python list. This is a list of so integers. There are anything else. Returns max A. Maybe instead of max A, I'm gonna be more descriptive. List max, like that. That's more descriptive to the reader, right? Like that, where did that A come from? Like the L was in there. Like if people were reading, like it would just be confusing if they were reading the documentation. List max. List max. Returns list max. This is an integer. And then the maximum of the list. So now we put in a docstring. So why are docstrings important in modern programming? Well, it's because there's help functions and things like I think that's a syntax. Yeah. So look what that just brought up. I typed question mark, find max, and then I get a description of it. That's the documentation for it. So now if someone else uses my algorithm that I have put in a nice little function, and they didn't know what it did, they could find out. And I cannot emphasize that enough in modern programming to do that, and how important it is, because you're sharing code constantly. At least like the languages I use, they're all open source, right? Like, and this is how you do it, right? Yeah.
That you want to share with other people. Normally just in that way build a package of functions that they can then access, or can they just access those functions?
I would, so the question is, if you want to share functions that you've written yourself with other people, how would you do that? In Python and in a lot of languages, you would write modules. And modules are scripts that contain functions, definitions, variables, algorithms, classes, things like that. And if you have that, then you can just like do that. So for example, like just because that question of how to share these things is an important one, let me just like, oh, I hate that I keep on doing this. I'm making so many useless files on my computer, and I hate how cluttered it's getting. So like, let me just like, I don't know, open just a random folder somewhere. Oh, I know what to do. Where is it? Documents. I know what to do. I went to teaching, UHD teaching, math 20 here. I can open that. Okay, so I've located this Jupyter notebook in my directory, right? And I opened up a code editor that's like actually built for like Jupyter notebooks are good for data science, visualizing, giving presentation notes. If you're gonna actually like deploy something, build something into an app or something like that, you're gonna use a code editor like VS Code or or like something similar. So like I have all my stuff here. I'm just gonna make a new like main.py script. And then I'll do like another script like helper functions.py like that. And then this is so like weird that I'm doing it this way. Just grab this thing, copy it, go back to my script. Inside helper functions, put that there. See the little dot right there? Means I haven't saved it. I save it. And then inside main, I can say from helper functions import find max. Like that. And then if I just have like a list in here, I don't know. Like that. Save that and just run it. You see that it found it right there. So like you could stack a bunch of functions in here, save that .py script, send it to someone. If they put it in their current working directory, they can get it. But typically you would put helper functions with like some other things inside of a directory, like a folder, name that folder something, and then put that, like give that folder to someone, and then they could put that in their like program, and then from that folder import like this or that, like whatever you need from it. So that's how you would do that. Yeah, they could. And that's where you would use something like version control that if they're going to modify anything. All right, so that was kind of a little tangent, but I think it is important to know how to share your code and how to kind of put it together in different pieces. So, okay, this is how you would write an algorithm to do this. Obviously, there's a Python way of doing it. There's the max keyword, like that. But this is just, it's good to write algorithms to do these things. You need practice, like you need as many examples, simple examples as you can get a hold of to refine your like writing pseudocode and things like that, okay? In fact, like you could probably like write the pseudocode in the description if you wanted to. So if you wanted to translate it from Python to another language, you could. That wouldn't be a bad idea. Okay, so what's next? Searching algorithms. So this was kind of like a search algorithm. We're searching for the maximum of the list. Oh, but before I move on, like we need to test this function more. Like we see that it worked on our list, but like what if we had like a weird list? Like what happens if like there's like a string and like someone puts a string in there, right? That'd be bad. Or what about if it's empty like that? Or like, what if it was just one element in there? Is it gonna work? Like you really should like, okay, that worked, right? If it's empty, there's a problem. So you'd have to somehow specify like a warning to the user, like if it's empty, then it's not gonna work. What about if they're all the same? Well, that should be fine because this condition will never be met and nothing's going to go wrong. It's going to be the first thing that it comes across. And so I think that, okay, the thing like has shown that it works to me. But I would, like if I was doing this in a professional way, like definitely put in some checks in there, right? Even for myself, like if I write a function and I come back to it like 6 months later, and I input something wrong, like why am I getting this type error? Where is the type error coming from? Especially like when I'm probably importing this function from some script or some module that I completely forgot about. And documentation is key. Checking for error, like I hope you get what I'm saying. Like these things are important to check for. Okay, so next up, I'm gonna make another markdown cell here. I like putting my little lines like that. This would be like searching algorithms. Okay, so and you would give like a description of what this is. Maybe I'll do that real fast. I don't know. I don't have like I'm lecturing in front of you guys right now. I'm not gonna spend time typing it out. Just talk to you, right? So searching algorithms are looking for the location of a given element in a ordered list. Right. So I'm saying sequence or list interchangeably. Python lists are not necessarily like they do imply an order, but they're mutable. Like you can mutate them. So like I get nervous about that. But yeah, just an ordered list of things. So maybe I'll type that out. So I'll type that a little bit. So searching algorithms finds a given element in an ordered list. Yes.
So, so that really says that we
Two.
could find. You passed it out, but you got 6, right?
Yeah.
So when I passed it out, I think it's 6.
For this exact same thing?
Yeah. I put it.
Well, I'll look at it after class.
Okay.
It's probably something very like it had most likely it's like an indexing error. Like something is off by 1 because of this the sliding that we had to do. Okay, so okay. So here's our problem statement now. And I'll help you with that after I finish today. Problem 2. Find the location of integer x in a list of distinct integers. That's the problem statement. So given some integer x, and we want to find this integer in a list of distinct integers. Okay. So, okay, how would we do this? Well, I guess kind of regretting doing the uppercase now. So I won't put in the name yet because we're actually going to do one that's like known. But I will put the input. I'll tell you the name after. So the input now is 2 things, right? We have a target variable, or a target value, I mean, and then also a list of things. So we have to be careful with how we do this. So, so maybe I'll say like x, that's an integer, and then a1, a2, comma dots, comma a n. It's typical to use n as like denoting like the order, the size, the number of things you're putting in. And that is a, what did I say up here? I want to be consistent. I'm going to say list of integers there. And down here, these are a list of distinct integers. Okay. And then the algorithm part. Okay, and then this is where like I started listing things up. Okay, so algorithm. All right. Well, basically, we just need to like scroll through the thing, right? And so scroll through this list, so is x equal to this one? Is x equal to that one? So forth and so on, right? Now, a for loop, we could use a for loop for sure. However, we would probably, if we're going to be optimal, like have to break the for loop somehow, right? Like because we wouldn't, if we found x at the very first entry, why would we keep on looping through, right? That's not what you want to do. So instead of a for loop, I'm going to use a while loop and a counter, an index to count through the thing. And when the while condition, whatever that condition is broken, we're out of the loop. Meaning if we found it, we're good. So let's kind of think about this. So I can say like index I, math type index I is equal to 1. And then bold while in bold. What do I want to do? I want to say while I is less like so. So yeah, so like while maybe like math type, I'm gonna do math type again here. While I is less than or equal to n. Oh, I can use this to like inside of math type. If you want to do text, you can do that. Space and like that. And x, let's see, not equals, so backslash not equals AI. Close out, let's see what that looks like. Yeah. So while I is less than or equal to n and x is not equal to a, we're just going to increment I. And the spacing here really bothers me. Oh, I know what I can do. This is like a hack. I'm going to go into math type like that. And I'm going to do text. And then there's put a bunch of text in there. Maybe that'll do it. I plus equals 1. Or no, I'll stay consistent. I is assigned to be I plus 1. Let's see what that does. Did it move it? It's hard to tell. And maybe I think this does space. I'm just trying to hack some space in there. Yes, that's how I get. Okay, those are the spaces. I'm gonna move it over some more. So backslash colon, looking better. Not quite happy with it yet. Copy that, paste it, go better. Okay, so what's happening here? So, well, go back to this. So I is 1, right? And if n is greater than 1, right, then this is satisfied, and this is logical and, just like in logic, right? So for this while loop, for things inside this while block to happen, this conjunction needs to be true. So if I is less than or equal to n, and x is not equal to ai, then we're going to increment I 1 time. And then we're going to check this condition again. So that's nice, right? So like if x was equal to a2, right? Then we'd go in here once, we'd increment I would be 2. And then this might still be true, but then, oh, x would equal a2, and the while loop would break, right? And what would the value of I be? It'd be 2, which means that like that's the location of x in that list, right? As soon as that breaks out, that's the location. Now, what if x is not in the list, right? That's a possibility. So that would mean what? So if I was 1, it wouldn't be there because x isn't in there. We'd increment I, we'd check there, keep on incrementing until finally we reached an I, which was equal to what? N plus 1, right? And then that would break out here. So if I is equal to n plus 1, that means that x is not in there, right? If I gets that big, if I makes it all the way to n plus 1, and that's what breaks this while loop, that means that we never found it because there's only n indices in there. So that's what I'm going to do now. I'm going to say, okay, for if, and then say I is less than or equal to n, that means we found it, right? So if x is less than or equal to n, then location is assigned to be I. Make sure that's in the italics. Okay, and then else, What do I want to say? Location equals to, yeah, so location and 0, whatever. Return location. So 0 would mean like it's not in there because the indices in this this list start at 1, go to n. So this actually has a name, and this is called the linear search algorithm. Notice that it does take care of that problem I was mentioning earlier. Like if we find it at the very, like anywhere in that list, we're out immediately, and we don't keep on performing operations. Okay, so now we have to adjust our brains for Python starting with index 0. So this right here is bothering me because there is an index 0. So maybe we'll return like the string no or something. It's just not 0. We have to like account for that. So, okay, so let's look at like L is equal to 3, -2, 1, 6, 10 or something. I don't know. So then we can say I is equal to 0 because we have to shift everything down by 1. Also, we need an n. N is equal to the length of L. Okay. So, all right. So while, okay, I is less than or equal to n minus 1, because the last index of L is n minus 1. It's the number of items minus 1, right? Shifted. And, oh, we need an x to test for. Let's say like, so this is where so let's do like -2 or something, right? And Li not equal to, or x not equal to Li, x not equal to Li, colon, I equals I plus 1. Or realistically, plus equals, it doesn't matter, plus equals 1, if you're used to coding. Okay, and if I, so if I is less than or equal to n minus 1, location equals to I. Else, location equals to the string not found or something. Okay. All right, so then let's see what happens. I just say, this is the algorithm, this is linear search. Let's see if it works. Location 1. 0, 1, that is the index location of -2. All right, so now let's put something that's not in there, 5, and let's see what happens. So what happened here? How would you find the bug? It seems like everything's working, right? Like 5 and like 0, 1, 2, 3. There isn't even a 5 entry in there, right? Where is the bug? How do you guys debug things when you're in your programming courses? Oh, wait a minute. What am I doing? There was no bug. It's location. But that print statement immediately told me exactly what, like I knew immediately when I looked at the print statement. So I was like, oh, I's incrementing. I went, oh, obviously I would be 5 because it broke out, right? I was looking at the location. Okay, so it's like, way 1. Get rid of that print statement now. So now obviously what would you do? You're gonna put this into a function, right? So let's go ahead and do that. Def linear search X L colon, save yourself time and just copy and paste. I wonder if Jupyter Notebooks allow me to do this. Yeah, just select it all and tab it over into the function. And then now we can finish it off with return location. And then look at linear search on X and L. Should be not found. It is. Are we done? Far from it, but it's a function to do it, right? But it's actually pretty easy to fix it. Just come over here, copy, come back down here, go in there, paste, finds the location X in of the integer X in the list of distinct integers. Oh. Do that. Parameters, I can just like copy that, come here, press return. That, so it takes X. This is a Python integer. I just, for some reason, int. I gotta be careful there, right? Because the first parameter is the Python list, this distinct integers like that. Returns location integer if X is found, otherwise is a string. That would be really important to know, because if you were using this function and one part of it returned a string and you weren't expecting it ever to return a string, that could really throw off a program, right? If you're using this on something. All right, so whatever, it's not the best documentation, but it works. That works. If I don't know what it does, I can just like, there. I press tab, by the way, to autocomplete that, and press shift enter. And then I have a bunch of documentation. And I can even like export it. Okay, so yeah. All right, so that's linear search. And next time we will, that'll be it for today. All right, I really want to get this video uploaded to YouTube so that you can like recreate it on your own. So that next time you can kind of like type with me. All right. All right, so that'll be it. I will see you guys next time.